All right, so translating parabolas. As we look at this, our goal today, yesterday, remember we talked about the most important point, which was the vertex. Let's do a little review while we're doing this. What's the dotted line that goes to the vertex? Axis of symmetry. All right, remember, raise your hand if you remember the equation to get you the axis of symmetry. How many? Don't say it. Let's see how many hands we can get. I know the equation for the axis of symmetry. Okay, now I'm going to start to say it. As you remember it, continue to raise hands. X equals the opposite of B over 2A. Okay, all right. So that was our equation for the axis of symmetry. And a little review here. Is this letter A crucial? What does that letter A tell us? One person, tell me. What does that letter A tell us? Catherine?
If it's
right. If it's upside down, so if A is negative, it's upside down, right? And if A is positive, it's right side up. Now, Trevor, you remember you did well on this yesterday. That dot right there, obviously that's called the vertex. When this vertex is at the top, do you remember what that was called? A max, okay. And vice versa, when the vertex is at the bottom, a minimum. Do you guys remember those ideas? Sebastian, you good there? All right. So that was called standard form. Useful for using as a system, using algebraically, but today I want to focus on a form that we use more for graphing. And a very quick way to graph. And it's called the vertex form. And the reason it's called the vertex form is because it's, honestly, everything's about the vertex on this one. On the other form, everything was about the axis of symmetry. Here, everything's about the vertex. And so the vertex is really nice to get in here. Here's our standard form of what we call the vertex form. I want you to notice the x minus h in the middle and the plus k. That's the location of the vertex. H, comma, k. You with me? H, comma, k. And the axis of symmetry is x equals h. So graphing today is going to be really straightforward and pretty simple to do. Now, I need you to remember with me, if I have another function like an absolute value function, remember we shifted them right and left and up and down? Do you remember that? On an absolute value function, if there was like x plus 1 on the inside, remember how that shifted it left? And if it was x minus 3, that shifted it right? And so here we have the same thing. When h is positive, the graph shifts to the right. So for example, x minus 4, which way does that shift? To the right 4 units. Or if it was x plus 3, which way does that shift? To the left 4 units. Isn't that just like absolute value? Same idea. And so for those of you who remember that, hopefully it will just flow through. Layla, question?
Wait, wouldn't it be switched?
Remember in our parentheses, it always goes the opposite direction of the sign. So since the sign on the inside is a plus 3, it goes negative 3, which is left. Oh, did I put 4 there? Sorry, left 3. Does that make sense? Now on the other one, up and down, that has to do with what's outside the parentheses. So if you had like a plus 2, it would be up 2. Or if you had something squared minus 5, that would be down 5. So what we're doing today is extremely similar to our absolute values. And if you can go back and think about a positive going up and a negative going down, that's just like the negatives and positives outside of the absolute value the same way. So it's just an absolute value that's kind of turned into a curve versus a sharp V. So that's kind of our overview. Does that make sense? Similar to what we've done before? I hope. So what I have is a couple examples we're going to do on here, and then I have a worksheet that we're going to kind of walk through together to practice to make sure we're solid. So Let's start. Raise your hand if you can tell me what the coordinates of the vertex are on our first equation right here. Raise your hand if you think you know that. A couple of us. Alejandra, go ahead.
Isn't it up to?
2 is the up. That's the y.
Yeah.
And then how far side to side?
And then you have to go right.
Exactly. So right 3. So everyone go to the right 3 and up 2 and put a dot right there. And that dot is our vertex. Axis of symmetry. Super straightforward here. X equals h. X equals 3. So it's right, Abby, just right at the value that we get from right there. So put a dotted line at 3. Now, find another point. I said it's wise to choose a point whose x value is close to the AOS. What do you think I mean by AOS? Axis of symmetry. Okay, just want to make sure we understood what those letters mean. What point is close to the axis of symmetry? 2? Okay, so let's try x equals 2. Y equals parentheses 2 minus 3 squared plus 2. Y equals parentheses negative 1 squared plus 2. So that's 1 plus 2, which is what? 3? So I have the point 2, comma 3. We okay there? Did I go too fast, or does that make sense? So plot 2, comma 3. And now what can you do? Flip it. Did we want this thing to go up? Did it go up? Okay, now, here's the fun part. If a equals 1 or negative 1, do you remember the patterns? Over 1, up 1. Over 2, up 4. What's the next pattern? Over 3, up 9. Now let's just see. Is our A positive or negative 1? Is it? What's the number right up here? Isn't that a 1? So we can follow our pattern. Did we go over 1, up 1? Over 1, up 1?
Yeah.
Yeah. So let's get our next point. Over 2, up how far? 4. Now realize I'm doing this, Sebastian, from the red dot. I'm not doing it from the blue dots. I'm doing it always from the red dot. Does that make sense? So on the other way, I go over 2 and up 4 again. I guess I really can't do the 3, 9 because it's way off the graph. But you can put it there for reference. Any questions? Does this make sense? Trevor, you good here?
Yeah.
Okay, so did I mention yesterday when we draw a graph, we want it to be curved at the bottom? So I always like to blow this up a little bit before I draw it. So I'm going to kind of sketch it here. But make sure as you're coming down here to the bottom that you're curved at the bottom and you're not like a V. It should be a curve, much like a very fine chain that hangs. It's in a curve there. And there we go. There's our graph. Now, I think this is easier than the whole axis of symmetry, opposite of B over 2A, plugging it in, finding, what do you think, Layla? Is it easier? Yeah. I feel like it is. So we need to be able to do both. Understand the standard form and the vertex form. Standard form is great for algebraic systems. Vertex form is great for graphing. And so it's just a different type of equation. Are we good to go on?
Yeah.
All right, sliding down. All right, here we go. Vertex. Talk with your neighbor. 10 seconds, come up with your vertex. Go. Good. Good. Put a big V next to that. All right. Joey, what'd you have? -1, -4. Do we all agree with Joey? All right. -4 comes from right here.
So you get to go, -4?
Because here is -1 comes from x minus h. What does h have to be to get a +1 there? Has to be a -1. So it's always, Lydia, the opposite of what is in there. It's the opposite of what goes in there. What I honestly think is, what number would I have to put in for x to make this parentheses right there equal to 0? Would you agree I have to stick in a -1? That's what I think to make it work for me. That's just how I keep it straight in my mind. So let's go to -1, -4. There we go. Now my axis of symmetry, x equals -1. So I draw my dotted line. Does this graph go up or go down?
Up.
It goes up. Okay. Choose a point that's close to the axis of symmetry.
0.
Yeah, I love that. X equals 0. All right. X equals 0. So we plug that in. Y equals 2, parentheses, 0 plus 1 squared minus 4. Y equals 2, parentheses, 1 squared minus 4. Y equals 2 minus 4. So we get -2. So we have the point 0, -2. Greetings to Haley, to Grace, and to Una on your bus drive right now, wherever you are. All right, flip that point. There we go. Now, you want advanced easy graphing. If you want it, I'll give it to you. All right. Do you remember the pattern for the A? 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9, right? Hold on. So this is advanced A graphing. 1 times 2, 2, 4 times 2, 3, 9 times 2. Why am I multiplying by 2? Because that's the value of A. A equals 2. A equals 2. A equals 2.
Why would you multiply the bottom by 2?
You don't. You only multiply the y by 2. You don't change the x. Change the y. Now, why is this nice? It just saves you from plugging in point after point after point. Zach, if you don't remember this, it's not the end of the world. You could just as easily, Zach, plug in the value x equals 1 and get the next spot.
Okay.
But I'm going to use this little trick here. Over 2 up 8. So over 2 up 8. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make that in purple. And there we go. Yes, ma'am?
I'm sorry, but could you explain that again?
I would love to. The value of A is 2. Do we agree with that? So that means my whole graph, Layla, is stretched vertically twice as high. So what used to be 1, 1 right here, I stretch that vertically twice as high. So 1, 1 stretched vertically becomes 1, 2. And 2, 4 stretched vertically becomes not 2, 4, but 2, 8 right here. And 3, 9 stretched vertically becomes 3, 18. You with me? Now, we could shrink it as well if that was like a 1/2 or a 1/3 or whatever. It just has to do with how much we're stretching or compacting. You can always go back and plug another point in if you'd like. All right, so spread yourself out. Go ahead and sketch this as best as you can. Here we go. Try to make a curve at the bottom. He's a happy parabola. There we go. He kind of has a face down there with the green eyes and the little red nose. Reminds me of Bozo the Clown. What's that? You think of that every
Or
time?
a dog. I draw a dog.
Nice. Very nice. All right.
I call it rough Debra. Because it's a dog.
All right.
Okay.
Okay, now here's my question before we move on. Does everyone feel like, given vertex form, they can draw the graph? Yeah. You good there? We're going to more practice later, but I want to make sure we were okay here. Now, I wanted to do the reverse. We're going to do the reverse now. Part 2. I'm giving you the graph, and we're going to write the equation. So let's look at the graph, and let's put a red dot where you feel the vertex is. Everyone put a red dot on the vertex. And I hope we all agree it's at the point 2, 0.
Yeah.
So therefore, what is the value of h? Somebody?
-2?
Just 2. And what is the value of k? 0. Okay, would you agree that that is important information?
Yes.
Okay. Now, I also have another key point here that I'm going to make a blue dot. I have the point 4, -4. Would you agree that this point has coordinates x, comma, y?
Yeah.
So let's watch. I have the y value, check. I have the h value, check. I have the x value, check. And I have the k value, check. What's the one value I don't have? A. So does it stand to reason that I can put in h, k, x, and y, and I solve it, and I'll just have a left?
Yeah.
Does that make sense? So let's do that. What's the value of y? -4 equals a, parentheses, what's the value of x? 4 minus, what's the value of h? 2 squared plus k, what's the value of k? 0. Okay, well we can do this. -4 equals a times 2 squared. -4 equals a times 4. I get a equals -1. Do we agree? Now let's see if that makes sense. -1 is the parabola going down. Right? So that's good, right? That's good. Now, second, look at the patterns. Over 1, down 1. Did that work? Change colors here to green. Over 2, down 4. Did that work? So does it follow the pattern of a value of 1? 1, 1, 2, 4, 3, 9. So that's kind of our check. So let's write the equation. Here we go. Going with purple. Y equals -1 times x minus 2 squared. Do I need to put plus 0? No. I'm just going to do like this, which represents we've thought about it, but it's not really there. And for that matter, I'm going to do this. Because in reality, Zach, they're not going to put -1. They're just going to put minus. So the equation, if this was in your textbook, would really look like this. That's what it would look like. And you have to assume that the 1 and the plus 0 are there. Does that make sense? We have to be able to see what's not there. All right? You're kind of believing. Can we move on? All right. I got another example for you. Who can tell me my vertex? 3, 4. So over here, let's put V 3, 4. What does H equal? Come on.
3,
3. What does k equal?
4.
4. All right. Do we have another point?
Yes.
5, -4. So we have a point. 5, -4. So my value of x is 5. My value of y is -4. We good? Luke?
Can you just go up to the last one?
I would be glad to. What's your question?
I just wanted to see what the equation was.
All right. Who feels like they can plug them all in for me? Zach, you have the floor. Speak nice and loud so Haley can hear you.
-4 equals a parentheses 5 minus 3 c squared plus 4.
Excellent. All right, let's keep going here. -4 equals a 2 squared plus 4. Obviously, 2 squared is 4. So a times 4. I just feel so funny writing A4 because I always think of Battleship, you know, and like it's a hit. Did any of you guys have the Battleship game that make the noises?
Oh, not.
It was awesome.
Noises.
Like you plugged it in and then it had this little ooh psh, if you missed, or ooh if you hit. All right, subtract 4 from both sides. Those of you who have the game can completely relate to me right now. Great satisfaction.
I've never done that.
Great satisfaction when you got the hit.
Well, yeah.
And then my brother would be very frustrated.
I'm never making that.
No, my game makes noises.
Your name actually has
Yeah, it makes noises,
That's
yeah.
so cool.
Oh.
All right, you have to come over and play it with Jessica. All right, so I get a equals -2. So staying back on track here. Here we go. So my equation is y equals -2, parentheses, x minus h, which is 3, squared, plus 4. Is everyone okay with how I got -2 there? Pretty straightforward. So let's go back here and let's just look at our problem. Would you agree that that dot right there falls pretty much on an intersection? How far is it from red to green? Over 1 and down what? 2. Does that follow our pattern? It sure does. Let's go from red to blue. Over 2, down how far? 8. Does that follow our pattern? It sure does. Okay, so we've kind of, we're learning how to decipher our graphs here. Questions. We've done 2 examples with graphs. Any questions on graph to equation? All right, any question on equation to graph? Absolutely not. Okay, so we have 2 different equations, examples of each one. Now I want to talk about some possibilities. What happens if the number here, the a value, is like 1/2? Do you remember what happens? Instead of being narrow, what happens to it? It gets wide. And so instead of going over 1 up 1, you might go over 1 up 1/2. Right? So you're just multiplying by 1/2 instead of multiplying by 1. So that's pretty much all I got. Here's our homework. Pretty straightforward. I will write it over on the board over there. Now, I did give you some stuff down here, make it a little easier for you. So if you'll notice down at the bottom, you've got your problems that might be a little bit easier for you. So hopefully that helps. But that being said, that's going to kind of wrap up our example portion. So let me stop this here.